This is example 3, design an arch. So to commemorate, please follow along in your book there or on your sheet. To commemorate the 100th anniversary of the Newtonville Fair, an entrance arch was built. So entrance arch. So we're going into some kind of fair. It's an arch and we're going to walk through it. So I'm guessing it looks something like that. Yeah? Maybe a little bit wider, I'm guessing. Just to give us a picture to think about. Here's the ground. I'm guessing that the ground is going to correspond to the x-axis, probably, maybe. Okay, the design engineer uses the equation h equals negative d squared plus 16 to model the arch, where h is the height above ground and d is the horizontal distance in meters. So we're looking at d, and up and down, we don't know where it is, but it's h. From the center of the arch. Oh, that's easy, so we do know where it is. So there's our h-axis, and this parabola is represented by h equals negative d squared plus 16. How wide and how tall is the arch? Well, how would we find out how tall it is? Do we already know how tall it is? 16 meters high, right? The vertex is the maximum point, so it's going to be 16 meters tall. A. Height equals 16, or I should say maybe maximum height, or height of arch is 16 meters. How do we find out how wide the arch is? How do we find the distance from here all the way across to here? How do we find this distance from here to here?
Midpoint. Midpoint.
I'm hearing distance formula. That might come into play. You probably won't need it. Do you know where these points are?
Yeah.
Could you find out where those points are?
Yes.
How? How do you find this point and this point? I'll give you a hint. They're your d-intercepts. Yeah, we can just put this in factored form and we'll get our zeros. So basically what we're finding is the height of the arch right at this point is 0. Right? When the arch hits the ground, the height is 0. Same over here, it's 0. So we're finding out where h is 0. We're finding what d is when h is 0. So all we're doing is putting this in factored form. So we've got h equals negative d squared plus 16. We don't really like this negative sign out front, so we're going to factor that out. It's going to leave us with d squared minus 16.
Would it be a 1? Negative 1? Yeah, you don't have the right one. Okay.
Yep, there's an invisible 1 there. And now we're looking at factoring this binomial. This follows one of the patterns that we have. It's a difference of squares, right? 16 is a square number and d squared is a square number. So we know this is d minus 4, d plus 4. Which tells us what? Yeah, so now if we set h equal to 0 and we get 0 equals these, then what has to be true is either this factor equals 0 or this factor equals 0. Well, what is going to make this factor equal 0?
4.
A d value of 4. So our d intercepts are positive 4 and negative 4. So how wide is the arch? If it goes from negative 4 to positive 4, width of arch is 8 meters. Good. B says, for what values of d is the relation valid? What does valid mean?
True.
True or useful or
Right.
true, I guess. Right. So what values of D is this relation valid? So where it's a real life situation of an arch. We know that the arch spans from -4 to +4. What do we know about the value 5, 6, 7 if this relation kept going?
If you made the parabola wider, is that what you're saying?
Not if we made the parabola wider, that we can't change the parabola, it's defined by this equation right here. But where would it be at 5, 6, 7, and -5, -6, -7?
You wouldn't need that.
You wouldn't need it because it'd be underground. So it's not considered at all. It's not valid. So where is it valid?
Up
At
to the
zero.
ground or wherever you're
The values of D. Which values of D is it valid at?
Need the foundation.
It's valid. Yeah. B.
Does need a foundation.
Valid for -4 greater than or D greater than or less. Sorry. D greater than or equal to -4, less than or equal to +4. So this is the domain of the function that it's valid for. We don't care about anything outside of those values because the arch is above ground. That's all we care about. C. If a width of 2.5 meters is needed per lineup at the entrance, how many lineups can there be? Well, we said we have a width of 8 meters, right? We have 8 meters. And if we needed to have our lineups here,
Divide that by 2.5.
we just divide 8 divided by 2.5. You'd get 3.2. So how many lineups can be accommodated? 3, right? Therefore, 3 lineups can be accommodated. The homework for 6.3 is listed at the bottom of your worksheet, and you may begin on that now.